Hello everyone, welcome to my YouTube channel. And today I will be talking about RAG, Retrieval-Augmented Generation. So, when you ask ChatGPT a question about your company's leave policy, it gives you a confident answer. Sounds great, except it's completely wrong, it's made up and it is hallucinated. So now imagine you are building an AI assistant for your company, for example, a customer support, for your internal docs, for legal contracts. You can't have your AI just making stuff up. So it needs to give an answer based on your data, your documents, and your knowledge base. So that's exactly what RAG solves. So RAG stands for Retrieval Augmented Generation, and it's one of the most important pattern in AI right now. By the end of this video, you will understand exactly how it works, why it matters, and what tools you need to build it yourself. Okay. So, all right. So what is RAG? Let me explain it in the simplest way possible. Think of a large language model like ChatGPT or Claude as a really smart person who reads millions of books, but they read them a year ago. So they have a great general knowledge, but they don't know what is your company's documents. They don't know your product specs, your HR policies, or your latest sales data. So now imagine you give that smart person a cheat sheet right before they answer your question. So you pull out that exact page from your documents that are relevant, hand them over and say, here, use these to answer the RAG. So that's the RAG. Okay, so let's move on to next slide. As you can see in the picture, so relying on the state memory and retrieving grounded knowledge. This is the difference between RAG flow and a standard LLM. So there are three steps for RAG. Okay, the first one is retrieve. So when a user asks a question, you search through your documents and pull out the most relevant pieces of information. We call these chunks. Step two is augment. So you take those chunks and attach them to the user's question. So now the LLM isn't just seeing the question, it's seeing the question plus the relevant context from your data. And third step is generate. So the LLM reads the question and the context and generates an answer based on your data, not from its training data. So not hallucinated, grounded in real information. So retrieve, augment, and generate. That's why it is called RAG. The name literally tells you how it works. So let's move to the next section. Yeah, so how actually RAG works under the hood? Let me explain. So the first part is ingestion. Now let's go a level deeper. Before RAG can work, you need to prepare your data. This is called the ingestion pipeline, and it's where most of your real work happens. First, you have to take your document, PDFs, Word, Docs, web pages, Notion pages, whatever you have, and you break them into small pieces. This is called chunking. You can't feed a 200-page document to LLM at all at once, so you need to split it into paragraphs or sections, maybe 200 or 500 words each. Next, you turn each of these chunks into a set of numbers. This is called embedding. So an embedding is a way to represent the meaning of a text as a list of numbers so a computer can compare how similar two pieces of text are. So you use an embedding model. For example, OpenAI provides text embedding 3, etc. Even Cohere has one. So there are many open source also. So after this embedding process, you go to the finally, you store these embeddings in a special database called vector database. This is like a search engine, but instead of matching keywords, it matches the meanings. So if someone asks, what is the refund policy? It can find a chunk that says customer can return items within 30 days, even though the words are completely different. So as the meaning is compared, so it can actually find the similar ones, even though the keywords exactly doesn't match then also. So next comes the second part, that is query flow. Now, here's what happens. When a user asks an actual question, okay, the user types their question, that question gets turned into embeddings using the same embedding model that we use for the knowledge base. Then the vector database searches for the chunk that are closest in the meaning to that question. It usually returns the top 3 or 5 most relevant chunks. Okay, those chunks get combined with the original question into a prompt. Something like, for example, based on the following context, answer the user question. This is the context, these are the chunks, and questions, questions, colon, then question, user's question. Yeah. So that prompt goes to the LLM. It could be GPT-4 or some Claude, Llama, whatever you want. And the model generates an answer grounded in your actual data. So under the hood, the similarity search usually uses something called cosine similarity. It measures the angle between the two embedding vectors. The smaller the angle, the more similar the meaning. It's elegant and it works really well. So as you can see here, you might have studied before in physics the vectors. If there are parallel vectors, they are more similar. Okay, so the angle is measured and we find the closest vectors in the vector database to that query. So let's move to the tools and stack. All right. So let's talk about the tools you would actually use to build this. I'll keep it practical. So some framework like LangChain, LlamaIndex. Okay, these are the frameworks you can use to connect the LLMs, vector DBs, tools in one pipeline. Most popular RAG frameworks are like LangChain and LlamaIndex, as it has the huge community, lots of examples, and simpler for pure RAG, less flexible for agents. So different types of frameworks are there. Like if you want more control, you can go through use LangGraph. Okay, if you want role-based access, CrewAI can be used. Okay, next comes the vectors DB. So in vector DB, there are some of the popular are Pinecone, Weaviate, ChromaDB, Qdrant, etc. So for coming to Pinecone, it's fully managed cloud vector database, scales easily. It is easy to start, no infra management, but it is a paid service. But in case of ChromaDB, it is lightweight, it is open source, great for local deployment and prototyping. Easiest to get started, but not built for massive production scale. So Weavit also is a open source vector DB with built-in ML models, can self-host, support hybrid search, etc. Next comes this LLMs. So in LLMs, you can use any OpenAI, GPT-4, Claude, Anthropics, and there are many popular LLMs for RAG, which have strong reasoning and instruction following schemes, protocols. Okay, we need to pay per token. The quality is great. Sometimes they can say it is expensive compared to DeepSeek and all. Okay. Next comes the infrastructure, which is like AWS Bedrock or Azure AI. You can use those also. So AWS Bedrock is a managed service for RAG with knowledge bases support that with multiple LLMs also. It is great if you already know AWS handles the chunking, embedding, retrieval for you. In Azure AI case, Azure AI Search plus OpenAI integration is there. It is enterprise ready with RAG pipelines. It has tight integration with the Microsoft ecosystem. So it is good for enterprises. Yeah. So here's the practical advice. If you're just learning or prototyping, use LangChain or LlamaIndex with ChromaDB and OpenAI. You can have a working RAG app in under an hour. If you are building for production, look at Pinecone or Weaviate for your vector database. Pick an LLM that fits your budget and quality needs, and consider AWS Bedrock or Azure AI if you want a managed solution that handles the heavy lifting. And here's the pro tip: LlamaIndex is a purpose built for RAG. So if that's all you need, it's often simpler than LangChain. But if you are building something more complex with agents, tool uses, and chains, LangChain gives you more flexibility. Yeah. So let's jump to next slide. Uh, Now this is a question that I get a lot. Like, why not just fine tune the model on your data? Why do you need RAG at all? So it's a great question. Here's the difference in the simple terms. Uh, Fine tuning is like teaching someone new information permanently. You retain the model so it knows your data. The problem is it is expensive. It takes time. And when your data changes, you need to retrain again. Plus, the model can still hallucinate because it learned the info loosely, not word for word. But drag is like giving someone a reference book at the time of answering. The information is always fresh because you are pulling directly from your documents, which are updated. If you update a document, the next answer uses the updated version. No retraining needed. Yeah. So to compare RAG versus fine tuning, the cost is low for RAG compared to fine tuning because fine tuning would need GPU hours for training. RAG is always current based on data freshness, reads the live docs, but the fine tuning is static, needs retraining. In hallucination risk, if we consider, RAG has lower hallucination risk as answers are grounded, but fine tuning has higher risk for hallucination because model may misremember. Next comes setup time. Like for RAG, it takes hours to days, but for fine tuning, it takes days to weeks. And RAG is best for Q&A, search, support docs, etc. But for fine tuning, it is generally used for style, tone, domain specific behavior. So in most real world cases, RAG is the right choice. It's cheaper, faster, and gives you more control. You can combine both, fine tune a model for your domain style and use RAG for factual answers. But if you're picking one, start with RAG. So now let's move on to common mistakes to avoid. Before we wrap up, let me save you some headache. Here are the top mistake people make when building a RAG system. Mistake number one is bad chunking. If your chunks are too big, you stuff the context with irrelevant information. If they are too small, you will be losing the meaning. Experiment with the chunk size. A good starting point is 300 to 500 token with about 50 tokens of overlap between the chunks. So the mistake number two is ignoring the retrieval steps. People obsess over LLM to use, but the quality of your RAG system is actually determined by how good your retrieval is. If you pull the wrong chunk, it doesn't matter how smart your LLM is, garbage in, garbage out. The mistake number three is not testing it. So you need to evaluate your RAG pipeline. Are the retrieved chunks actually relevant? Is it generated answer accurate? There are tools for this. So Ragas is a popular framework for evaluation. LangSmith is also there. So if you want to check if your answers are faithful to the context and if the context is actually relevant to the question. So this is what you have to do. The third mistake that people do. Now, number four is skipping the metadata. Adding metadata to your chunks, like which document it came from, the date, the section title, lets you filter results more precisely. It's a small thing that makes a huge difference because we can also find the audit trail, like from where the exact answer came and when. Yeah. So this section actually shows you have built RAG systems and hit real problems. So it builds massive credibility if you know these type of things in your interview. Next comes a recap. So, all right, let's wrap up with a quick recap. Okay, RAG stands for Retrieval-Augmented Generation. It's a way to give LLM access to your own data so they stop making things up. Okay, it works in three steps: retrieve relevant chunks from the vector database, augment the prompt with the context, and generate a grounded answer. Under the hood, you need a chunking strategy, an embedding model, a vector database, and an LLM. For tools, LangChain and LlamaIndex make it easy to build. Pinecone, Weaviate, and ChromaDB for storage. OpenAI or Claude for regeneration. And if you want a managed experience, AWS Bedrock, Azure AI have you covered. And remember, retrieval quality matters more than LLM choice. Get your chunking right, test your pipeline, and use the metadata. So if you found this helpful, then hit a like button, subscribe, and drop a comment telling me what topic you want me to cover next. I'll see you in the next one.